Alright, welcome to 7.3 Complex Fractions. These sound horrible, they're really, really easy. Complex fractions are things that look like this. They're fractions within fractions, right? So they're rational expressions within a numerator or a denominator. So if you really look at this part right here, that's the numerator, whereas this part right here, that's the denominator. So that's all they're saying, is you've got a multiple level fraction. You may be panicking. You may be thinking, oh my gosh, how can I do this? This looks so hard. In fact, addition and subtraction is harder than this. Like eons harder than this. Because when you really think about what a fraction is, it's just a division problem. Remember? So if you think about just a regular fraction, 2 over 1. That's 2 divided by 1. That's 2. 4 halves is the same thing as 2 whole pieces because it's 4 divided by 2, right? That's just 2. So if you think about these instead of fractions, you think about these more as division problems, then we can see that they're going to be quite straightforward to solve. So let's just think of these as division problems. Let's rewrite this one. I've got, here's the numerator, x plus 1 over x, divided by the denominator, x minus 1 over 2x. Yeah, they're both fractions, but now it's something we've seen before. Okay, so rewrite it as a division problem. They are no longer complex fractions. Alright, now if we recall way back to 7.1, in order to divide two rational expressions, I need to use the reciprocal. So the first one stays the same, x plus 1 over x, times now, instead of dividing, 2 over x minus 1. Right, so instead of divided by this one, I'm multiplying by the reciprocal. Then I can play the cancel game. I have to be super careful though. Well, I can put them over one fraction. We can start with that. So I have x plus 1 times 2 times x over x and x minus 1. The only thing that cancels here is that x and that x. I end up getting 2 times x plus 1 over x minus 1. And I can see that nothing else cancels. You're welcome to multiply out the top, but it is not necessary. Because we're not adding or subtracting. If we were adding or subtracting, we want to add and subtract everything. We want to multiply everything out, then see if anything cancels. Here, we know nothing's going to cancel. And that's complex fractions. Let's try another one. Let's change this one to a division problem. So I've got 2 plus 1 over y, right? And now instead of over that, it's going to be divided by, put this one in parentheses, the denominator, 3 minus 2 over y. Alright, now you may be thinking, okay, but from here, where do I go? Can't find the reciprocal yet because they're both kind of mixed numbery looking things. So let's change these both into improper fractions. Let's do this first one over here. I have 2 plus 1 over y. Well, remember that 2 plus 1 over y is the same thing as 2 over 1 plus 1 over y, right? Any whole number is the same thing as that over itself. My LCM here, a 1y, right? LCM is 1y. And so here I have everything, but in the first one I'm going to need a y. So I'll multiply the first one by 2 over 1 times y over y, plus 1 over y times 1 over y, right? Or 1 over 1 times y. And I end up with 2y plus 1 over 1y. So that's my new fraction here. 2y plus 1 over y divided by. Okay, so I've changed this guy by giving him an LCM, just like I did in the last section, right? Let's do the same thing for the other one. I have 3 minus 2 over y. Again, I have, this is the same thing as 3 over 1 minus 2 over y. Once again, my LCM is just a y, right? Times 1, technically. The first guy is missing a y, so I end up with 3 over 1 times y over y, minus 2 over y times 1 over 1, really, but the 1 over 1 doesn't really do anything. And so I end up with 3y, that wasn't writing, Miss K. Try that again. 3y minus 2 over y. So I'm dividing by 3y over 2, or minus 2 over y. Fabulous. Now I can multiply. I'll switch those guys, or I'll actually divide, right? I switch it. So I get 2y plus 1 over y times, this time, y over 3y minus 2. Use the reciprocal. And I can see that these guys cancel, and my final product is just, or sorry, my final product would be 2y plus 1 over 3y minus 2. Oops. So nothing new. Adding and multiplying together. Adding and dividing together. Not anything new. It's just combining fractions. Really, if you want to think about this section as combined fractions, then you can. It's the same thing. Let's keep going. Go nice and small. So I've got 2p plus 5 over p minus 1. 2p plus 5 over p minus 1. Instead of over this thing, I'll say it's the same thing. It's divided by this thing. 3p minus 2 over p. So that's really what's going on here, right? In order to be able to flip the second one, I got to make them both fractions instead of these, polynomial, rational nonsense things going on here. So I will start with the first one. 2p plus 5 over p minus 1. That's the same thing as that over 1, right? So the only thing that's missing is the first guy is missing a p minus 1. So we'll do 2p times p minus 1 over 2p, oh, I'm sorry, there's no 2p on the bottom, over p minus 1. Plus, 5 over p minus 1. That ends up giving me, since it's addition, I actually want to multiply that out. That's 2p squared minus 2p plus 5 over p minus 1. Yep. Put that up here. I'm going to move this over real fast. So we may need more room. All the way over. Okay. So we originally had not green, purple. So we had 2p plus 5 over p minus 1 divided by 3p minus 2 over p. Yes? Yes. Okay. So now what we have is 2p squared plus, minus 2p plus 5 over p minus 1 divided by. We're going to come back, and now we'll do the other half. Okay, so we may have to worry about the fact that this is a trinomial, but we won't worry about it now. Let's keep going with the other side. So the other side says 3p minus 2 over p, right? That's again 3p over 1. Looks like what's missing from the bottom is a p. So we get 3p times p, 3p over 1 times p over p minus 2 over p, technically times 1 over 1. If you want to put that there, you can. We end up getting 3p squared minus 2 over p. It's divided by 3p squared minus 2 over p. Alrighty then. Now we can flip the second part. So now we'll actually do the divide part. So we have 2p squared minus 2p plus 5, which is actually prime. We actually can't multiply, or we can't change that into two binomials. So we could try, but I don't think anything multiplies to 10 and adds to negative 2. In fact, I'm like 100% sure. So it's still over p minus 1. This will be times p over 3p squared minus 2. Alrighty. And 3p squared minus 2, also not very factorable. Okay, cool. So now we can, you know what, I'm going to zip around here. We're going to go down here. So now we can actually multiply these together. We get, let's see, over here, we get 2p cubed minus 2p squared plus 5p. So I multiplied the tops over p minus 1 times 3p minus 2. Again, that trinomial is unfactorable, so this is our final answer. P squared, pardon me. P squared? Yeah, P squared. Not very pretty, but that is what our complex fraction ends up being. Fantastic. Alright, let's do another one. Yeah, let's do this one. Just gonna kind of close off this. We can keep our thoughts in order. Here we go. So I have this complex fraction. I'm going to rewrite it as a division problem. 2 over x minus 3 divided by 5 over x squared minus 9. Remember, I've actually done nothing. I've just rewritten it as a division problem instead of a complex fraction. It's the only thing I've done. Let's go ahead and switch that. So 2 over x minus 3. Now instead of divided by this, I'm going to multiply by its reciprocal. Luckily, these aren't of this form, so I don't need to change those. And let's see, that top left one looks like a special case to me. Times x plus 3, x minus 3 over 5. And notice, everything here is being multiplied. So there's no LCM, right? There's no missing pieces. There's no addition, no subtraction. So watch out. Not every single time will you need to use addition. It's only when you're given things like this, right? When you have to make it into one fraction. If you're given addition, you have to do addition. If you're not given anything that's being added, you don't need to use the addition part. All I notice here is that the x minus 3's cancel. So I don't need to go find an LCM between these two because they're not being added. There's no least common multiple for multiplication. So my final answer just ends up being 2 times x plus 3 over 5. That one was much simpler. Alright. One more and then we'll talk about something else. I have 1 over x plus 1 over y divided by 1 over x squared minus y squared, 1 over y squared. This one I have some addition, so I will have to use the addition part, the LCM. Let's go piece by piece though. So first let's rewrite this as 1 over x plus 1 over y divided by 1 over x squared minus 1 over y squared. I can't exactly flip the second one if it's not one fraction, so let's change these both into one fraction. Got 1 over x plus 1 over y. LCM here is going to be one of each piece, or x and y, right? An x and a y. What's missing from the first one is a y. So I'll multiply this by y over y. What's missing from the second one? An x. So I'll multiply this by an x over x. We end up getting y plus x over xy. Okay, so this is now equal to y plus x over xy. Alright, let's do the second part. We have 1 over x squared minus 1 over y squared. What's missing, or what's the LCM? An x squared and a y squared, right? So what's missing from the first one? X squared is a y squared over y squared, right? What's missing from the second one? An x squared over x squared. And we end up getting, let's see, y squared minus x squared, difference of two squares, over x squared, y squared. Let's head back up here. Now multiply by the reciprocal of this, which puts the x squared, y squared on top, and the y squared minus x squared on bottom. Okay, so you may have just heard me say that this is the difference of two squareds. So this would be y plus x squared over xy times x squared, y squared over this guy right here. He is the difference of two squareds. So y minus x, y plus x. And those two guys cancel. Those two guys are going to cancel, leave me with an x up here. Those two guys are going to cancel, leave me with y up here. My final answer is going to be x, y over y minus x. Fabulous. Alright. So, if you need to find the LCM, you can do so. That's why we spent an entire section on it, right? So adding fractions, changing complex numbers into division problems, and then if you need to, use the LCM to make them both one fraction, multiply them, and reduce. Okie dokie. The last thing we're going to talk about today is a little blast from the past, the negative exponent rule. Remember, when you have something to a negative power, it's 1 over something that positive power. So for example, 1 over, now let's do 2 to the negative first is the same thing as 1/2, right? Or vice versa. If you have 1 over 2 to the negative 1, that's the same thing as flip, reciprocal, and the positive version. So this would be the same thing as a 2. So just keep that in mind as we're working with something like this. So I have m to the negative first plus p to the negative second over 2m to the negative first minus p to the negative first. Sorry, negative second minus p to the negative first. Let's start by changing all of these to their reciprocal version. Okay, so we're going to change these to their reciprocal version. So I have 1 over m plus 1 over p squared. Those are the two reciprocal versions of that. Over 2. Now this is we're going to come back to this one in just a sec. Let's change that second one first. So minus 1 over p. But look at that closely. Look at that closely. Does that mean it's 1 over 2m or 2 over m? It's actually 2 over m. Remember, if it's not in parentheses, that 2 is not a part of the exponent. It's different. Okay, so the 2 is not part of the exponent here. Now we have this new complex fraction. Alrighty. We can rewrite that as 1 over m plus 1 over p squared divided by 2 over m minus 1 over p. So that's our new division problem. Change the first one. I have no room here. Okay. 1 over m plus 1 over p squared. I'm missing so the LCM is going to be an m and a p squared. So from this first one, I'm missing 1 over m times p squared over p squared, plus the second one, I'm missing an m over m, and I end up getting, let's see, p squared plus m over p squared m. Okay, so that's the first part. I'm going to go ahead and erase this. Need lots more room in these notes. The second part, make orange. I have 2 over m minus 1 over p. So my LCM is just going to be an m and a p, not a p squared. So I have 2 over m. What's missing is a p, right? Minus 1 over p. What's missing is an m, so m over m. I end up getting 2p minus m over pm. Alright, so now I have to divide these two. So p squared plus m over p squared m. We'll change this to a multiplication by multiplying by the reciprocal, so pm over 2p minus m. The only thing that's going to cancel is an m and an m and a p and a p, so I'm left with p squared plus m over p times 2p minus m. Yep, and since neither one of those is going to be a special case or factorable, that is our final answer. Okay, so it's the same things as the last problem, you just got to change it first. Okay, I'm only going to do one more because I feel like I'm going to need the room. And I'm going to do this one. Okay, so I'm going to do this problem. Alright, so I'm not going to do this one. I'll probably do it in class, but I'm not going to do it here. x to the negative second minus 2y to the negative first over y minus 2x squared. Okay, so I have to rewrite this first off as 1 over x squared minus, again, there is no parentheses, so that 2 does not apply to the negative 1, right? It's 2 over y, right? Over y minus 2x squared. Yep. Okay, we'll rewrite that as a division problem. So this equals 1 over x minus 2 over y, minus 2 over y, divided by y minus 2x squared. Okay? Now I need to flip this second part, right? I need to flip the second part, and I need them both to be one fraction. Remember that this is over 1. It's over 1. So I still can flip it, even if it's a even if it's a quote-unquote integer polynomial, right? But I'm going to start by making this first guy into one fraction. Let's see, LCM of x and y, the two pieces. The first guy is missing a y. Y over y. Second guy is missing an x. And so this one becomes y minus 2x over xy. So that is equal to y minus 2x over xy. And that will now be multiplied by 1 over y minus 2x squared. Is that 2x squared? Yep. Oh, I'm so sorry. This was an x squared. So that's squared. It should be squared and squared. It should be squared and squared. It should be squared and squared. Sorry about that. Squared, squared. That way, yes, that way it looks nice and pretty like the problem I was hoping it would turn out to be. These two guys cancel. I'm left with 1 over xy. Okay, don't drop your squares. Alright, again, this whole chapter, it's not a lot of new stuff. It's a lot of just fractions, okay? But if you are ever stuck, okay, I'm not saying that you should be able to just magically get this. If you're ever stuck, you need to remember that a big part of this class is getting your questions answered. So if this video didn't help you, you need to email me as fast as you possibly can, and hopefully I can walk you through your problems, okay? Other than that, I will see you in the next video.